Hey guys, in this video the brilliant Mr. B is going to be working you through algebraic long division. Now these are some quite tricky examples in this video here, 9 worked through at a nice slow pace. You can use this as part of your revision for your GCSE, level 2, level 3, further maths, or if you want to get a head start on A level, then you can use this video to sort yourself out over the summer. There are also loads and loads more questions for you to practice with over on my website.
We are going to have a look at algebraic long division. Now, this topic is quite a difficult topic, so stick with it. It might take a few questions before you fully understand it. Now, we're starting off with an expression. We have x cubed plus 3x squared, take away 10x, take away 24. And we have to show that it's got x plus 2 as a factor. And we have to use long division because there's another way to show it's a factor, which I'll show you later on. Now, what this means, we have to divide this expression by x plus 2. So we're going to set up a bus stop method, like we normally would with division. But as you can appreciate, since it uses algebra, it's going to be a lot more complicated. Now, it isn't really possible to divide each term by x plus 2. How do you divide x to the power 3 by x plus 2? The best you're going to be able to do is write an expression where you say, right, x cubed divided by x plus 2. And you're going to have to leave it there. There's nothing you can really do with it. So the division itself is barely possible. So what do we do? How can we possibly do this? Well, the key is we're only going to do a partial division. And the partial division we're going to do is we're only going to divide by the x term. We're not going to divide by the plus 2. Now, obviously, that'll give us the wrong answer, but we're going to adjust for that as we work through the problem. So the first thing we're going to do is we're going to divide our first term, x cubed, by the x. I'm just going to write over here what we're doing. So we're just taking the x cubed, we are dividing it by x, and x cubed divided by x is x squared. Now, if you're not sure about how that bit works, well, that's using the laws of indices. I need to go back and revise that because you'll be very, very confident with your algebra before you'll be able to fully understand this topic. Anyway, we've done x cubed divided by x, we've got x squared. So normally in a division, you might be tempted to write it right above and write x squared there. But what we're going to do here is we're going to kind of keep the different powers together. So if our answer is x squared, I'm actually going to write that above the 3x squared in the original expression. So I'm going to keep all these squareds together. So obviously that's the wrong answer because we didn't divide by the plus 2. So this is now the part where we correct it. So we say, right, let's work backwards. We are going to multiply the x squared by x plus 2. Now, obviously, we do x squared multiplied by x, we're going to get back to the x cubed. Now, the bit we haven't taken into account yet is multiplying the x squared by the plus 2. So x squared times 2 is going to give us 2x squared. And now we've done the first round of this. So we've divided by x and only divided the first term. But then we've got our answer, we've gone back and corrected it because then we have to take into account the plus 2 that we didn't use in the original division. And what we're going to do now is we're going to do a takeaway, and we're going to take away the 2 expressions we have here. Because again, what we have here is only a partial division. And so we've only accounted for part of the expression. If we take away, we'll see what's left over. So when we do the takeaway, x cubed take away x cubed is 0. That means that our division is now totally accurate for x cubed. That bit's fine. When we then look at the 3x squared and 2x squared, when we take those away, we get 1x squared. So that means that we only have part of the x squared terms that we need. And then we haven't actually used the last 2 terms, so they are going to stay there. We're taking nothing away from them. So again, by dividing by that x, we're now left over with x squared minus 10x minus 24. And now we have to do more divisions to account for that last little bit. So what do we do now? Well, we repeat the process. So we take the x and we divide our remaining x squared term by it. So we've done x cubed, now we're doing x squared. So let's write down what we're doing. We have x squared, we are dividing it by x, and that should give us x. X squared divided by x is x. So I write that on the answer line. Now, again, we didn't account for the plus 2. We didn't divide by the plus 2. So now we have to account for that. So we're going to multiply our x by our divider. So we're going to do x times x is x squared. Then x times 2 is 2x. And then that's this part of our equation done. So now we're going to do our takeaway again. And you'll notice that when we do our takeaway, the first two terms are going to cancel out and give us 0. Because we've got to progress as we go through, so we've got to kind of eliminate a term each time. But when we look at the x's, we've got negative 10x, take away 2x. Be careful with negative numbers, that'll give us negative 12x. Then we haven't done anything with a 24. So now we have to go into another phase of our working out. So this time I'll highlight this in dark purple. And we're going to divide x, moving along to our next term now. So we've done x cubes, we've done x squareds, so now we're just looking at x's. So we divide negative 12x by x. So I'm going to write that down, negative 12x divided by x, and that is going to give us negative 12, and we can put that on our answer line. So now what we need to do is account for the plus 2 we didn't divide by, so we're going to multiply back. So we're going to do negative 12 times x is negative 12x. Again, notice it's exactly the same as what we have above, and then negative 12 times 2 gives us negative 24. So now we set up another takeaway. And if we take these away from each other, negative 12 take away negative 12 is 0. Negative 24 take away negative 24. Negative take away negative makes us positive. So negative 24 plus 24 will give us 0. And now we've finished our algebraic long division. Now, how have we shown that x plus 2 is a factor? X plus 2 is a factor if the remainder of the long division is 0. So we have remainder 0, therefore, just use the therefore symbol, x plus 2 is a factor. If the remainder wasn't 0, then that would mean that x plus 2 isn't a factor. So we've shown that we can divide our expression, x cubed plus 3x squared, take away 10x, take away 24. We've shown that we can divide it by x plus 2, and we can divide it completely with remainder 0. So take some time, have a look through this, have a look through the 3 steps we took. We had the green step where we divided x cubed by x. We've got the pink step where we divided x squared by x. And then we've got the purple step where we divided negative 12x by x. And that's how we got the answers on the top of our bus stop method, the x squared plus x minus 12, which is also a factor actually. But then remember, we had to do the adjustments. Every time we got one of those 3 answers on the top, we had to multiply it by our divider to correct it, because we never actually divided by that plus 2. And so the second term that you can see under each one in the 3 different colours, the plus 2x squared, the plus 2x, the minus 24, they're all kind of the adjustment we've made, because we haven't divided properly. So we'll go back and multiply and actually see what we should have started out with to get that. So let's move on now to another example. So our next example, we have x plus 3, and that is what we're going to divide our expression by. And our expression is x to the power 4 plus 9x to the power 3 plus 29x to the power 2 plus 39x plus 18. So this one's going to be a little bit longer. So again, we can't divide. We've got 5 terms here, and we can't divide them by x plus 3. So we're only going to divide them partially. So we'll start off by dividing by x. So I'm going to divide x to the power of 4 by x. And x to the power of 4 divided by x will give us x cubed. So we can write that on the answer line. Now again, that's not a correct answer because we didn't divide by the plus 3. So now we multiply it back by our divider to correct it. So x cubed times x is x to the power of 4, and x cubed times 3 is 3x cubed. So now we do our takeaway. So when we take away, the first 2 terms cancel out to give us 0. So that means that our division was accurate for the x to the power of 4 term. But what the plus 3x cubed means is that we got a little bit extra that we didn't really want because we couldn't do the proper division. So we have to take that into account. So we take that off. 9x cubed take away 3x cubed is 6x cubed. So actually the error, the 3x cubed, was helpful because it's actually taken off part of the expression we need to find anyway. Now the rest of it we haven't touched. So take away 0 from 29x squared, and take away 0 from 39x, and take away 0 from 18. So that's kind of our first phase done. So now I'm going to work in purple. I'm going to take the x and I'm going to divide the cubed term. And it's important we're not dividing the 9x cubed, we're dividing our brand new cube term, which is the 6x cubed. So we can take that over to the side, 6x cubed divided by x, and that will give us 6x squared, which we can write on the answer line. I just remembered what we should probably do here is actually write it above the x squared terms, which I said in the first question. So we'll just rub this out and move it over. So just make sure everything's lined up. So now we need to multiply 6x cubed by our original divider, the x plus 3. So 6x squared multiplied by x is 6x cubed. So again, the first term's always a repeat. But then multiplying it by 3 will give us 18x squared. So now we can take away. The first two terms cancel out, but then we have 29x squared, take away 18x squared, and altogether that will give us 11x squared. And then we've taken away 0 from 39x and taken away 0 from the 18, so they stay the same. So moving on again, I'll do the next one in pink. So we've done the x to the power of 4 term, the x cubed term, so now we're going to divide the x squared term. So we'll take that over to the side, we have 11x squared. We're dividing it by x, that will give us 11x, and we can line 11x up on our answer line above the x terms. So there it is. So now we have to multiply that by a divider to account for any errors caused by the plus 3 not being used. So 11x times x is 11x squared, but 11x times 3 is going to give us 33x. So now we can do our division and we can see what we have left over. So 11x squared take away 11x squared is 0, of course, but then we've got 39x take away 33x, which is 6x, and 18 take away 0, which is 18. So now we have one step left. So again, taking a different colour, we've done x to the power 4, to the power 3, to the power 2, so now we're doing x to the power of 1. So each time we're dividing by an x term that is just one shifted over. So we have 6x, we are dividing it by x, and that will leave us with 6, which can go on the answer line. Multiplying that by a divider, 6 times x is 6x, and 6 times 3 is 18. So now, as you can see, if we do another takeaway, you can see we've got the two terms are exactly the same. So if we take them away from each other, we are going to get 0. So then we can write that we have remainder 0. If it's remainder 0, that means that therefore x plus 3 is a factor. And again, if we got something else, we didn't get a 0, we got another number, then we haven't proven that x plus 3 is a factor, because the remainder has to be 0 for it to be a factor. So again, now take some time to have a look through, have a look at the process that we've done. So we've divided all 5 of the terms in our original expression by x, or rather, we were done after the first 4 actually, because the last one cancelled out to make 0. So we've divided all of the x terms by x. Then we've done an extra step. We've actually gone back and multiplied by the plus 3 as well, because we didn't divide by the plus 3 to start with, because that would be impossible. We can look at the effects of dividing by the plus 3 and kind of work backwards from there and make the adjustments, as you can see. Moving on to the next example, we have x plus 4, and that is what we're going to be dividing our expression by, and it is 4x cubed plus 14x cubed plus 16x squared plus 26x plus 24. So again, we're going to be doing some partial divisions, and we're only going to be dividing by the x. We're not going to divide by the 4 just yet. And we're going to divide the first term by x. So let's do our working out. 4x to the power of 4 divided by x will give us 4x cubed. And write that on the answer line, lined up with the cubed terms. Now, obviously that's not right, because we didn't divide by the plus 4. So now we're going to deal with that, and we're going to kind of work backwards and see what we should have had to start with. So 4x cubed multiplied by x gives us 4x to the power of 4. Then 4x cubed multiplied by the 4 will give us 16x cubed. So now we can take away, and we can see what we've got left to divide. So again, the first two terms cancel out to make 0, but 14x cubed take away 16x cubed will give us negative 2x cubed. And then for the rest, we are only taking away 0, so the rest stays as it is. So now moving on to our next step, we're going to still be dividing by just x. We're going to move on to the next term. So we've done x to the power of 4s, now we're going to do x cubes. Now remember, because our original divided by x wasn't correct, we had to take into account the plus 4, We're not going to be dividing the 14x cubed in the original expression. We've adjusted it now for the plus 4. So we're going to be dividing by the negative 2x cubed. So let's take negative 2x cubed. We're going to divide it by x, and that will give us negative 2x squared. And that goes on the answer line above the squared terms. So let's multiply it by a divider and see what we should have had. So multiplying by x gets you back to the original term, but then we have to multiply it by the 4 as well. So this is where the adjustment is. So negative 2x squared times 4 will be negative 8x squared. So again, we do our takeaway to adjust for that plus 4. So the first two terms give us 0, but then negative 16x squared take away negative 8x squared. A takeaway negative means we're adding. So negative 16 plus 8 will be negative 8x squared. And then we are taking 0 away from the last two terms. So they stay as they are. So now moving on to our next term, we're dividing by x. We've done power 4 and power 3, so now we're doing power 2. So we take negative 8x squared. We divide it by x, and that gives us negative 8x. Pop that on the answer line. Now we take into account the plus 4, so if we multiply negative 8x by x, we get negative 8x squared again. If we multiply it by the 4, that will give us negative 32x. So do the division, work out what we've got left over. And so we're going to have negative 26 take away negative 32. Again, it's a double negative, so it'll be negative 26 plus 32, and that is going to give us positive 6x. And in the final term, we're taking away 0, so it stays as it is. Now we move on to our last division. So we're dividing again by x. Now we're dividing the x term. So we have 6x divided by x, which gives us 6. Pop that on the answer line. And then we're going to multiply that by x plus 4. So 6 times x is 6x, and 6 times 4 is 24. So we can see now we've got the same thing on both lines. That means when we take away, it's going to give us 0. And again, remember to write a little sentence at the end. It remains a 0. Therefore, now for that space, we'll drop down a little bit. X plus 4 is a factor. And again, if the remainder wasn't 0, then x plus 4 would not be a factor. The next question is phrased a little bit differently, but it is actually the same method. So we are dividing a cubic term by x plus 7. We're not being asked to show that it is a factor. So x plus 7 might not actually be a factor. So let's have a look at it. So same method, we have x plus 7. We're going to do a bus stop method, and it's x cubed plus 6x squared plus 11x plus 6. So again, we're going to divide by x. We'll ignore the 7 for now. I'm going to divide our first term by x. So x cubed divided by x is x squared. Pop it on the answer line and place it above the x squareds. Now we need to adjust for the plus 7 that we ignored. So we're going to multiply by our original divider. So x squared times x is x cubed, and x squared times 7 is 7x squared. So now we need to adjust for that plus 7, so we need to take this away and see what we've got left over. So again, x cubed, take away x cubed is 0. That first term should always give you 0. And then we have 6x squared, take away 7x squared, which will give us negative 1x squared. And then we take away 0 from the rest, so they stay as they are. So let's move on. We're still dividing by x, but now we've done the x cubed term, let's do the new x squared term. That's negative x squared divided by x, which will give us negative x. And we can place that on the answer line. Multiply that by our original divider. Negative x times x is negative x squared, and negative x times 7 is negative 7x. So now let's do our takeaway to adjust. So negative x squared take away negative x squared will give us 0. 11x take away a negative 7x, a double negative. That means we're adding, it's going to be 18x. And we're taking 0 away from the 6. So moving on again, we're still dividing by x. We've done our cubed and our squared terms. So now we're doing our x to the power of 1 term. That's 18x divided by x, which is 18. that can go on the answer line. But now we need to adjust for the plus 7. So 18 times x is 18x, and 18 times 7 is going to give us, I'm just going to use a calculator for speed here, it's going to give us 126. So then we do our takeaway. 18x take away 18x is 0. And then 6 take away 126 is going to give us negative 120. Now, if we keep going, we need to divide this by x now, and we can't divide this by x because every time we divide by x, we've got an x in the term we're dividing, and you'll see with each one of these, the power goes down by 1. Now, with this, there's no x to kind of simplify away, so we're finished. What that means is that we have a remainder. The remainder is negative 120. That means, if you think about the previous questions, x plus 7 is not a factor. It does not divide nice and cleanly with no remainders into our expression. So what's our final answer in that case? So you would write down our answer is x squared minus x plus 18, and then remainder negative 120. Moving on to the next question, we are dividing by x plus 2, and the number we are dividing is x cubed minus 4x squared plus x plus 6. So again, we can only start off with a partial division. We're only going to divide by the x. I'm going to divide x cubed. So we do x cubed divided by x, which gives us x squared. Pop that on the answer line. Adjust for the plus 2 that we haven't used yet. So x squared times x is x cubed. X squared times 2 is 2x squared. So we've only done part of the division so far, so we've got to take away what we've accounted for so far from our original expression. That will give us the cube terms will cancel out. Negative 4x squared take away 2x squared will give us negative 6x squared, and we're taking 0 away from the rest, so that stays the same. Moving on with our division, so let's divide by x again. And we've done the cube term, so now we'll do the new squared term. And again, it's now your adjusted expression you're working with. We're not working now with the original expression. So negative 6x squared divided by x is equal to negative 6x. Pop that on the answer line and multiply by the divider to account for the plus 2, which we didn't divide by and we should have. So negative 6x times x is negative 6x squared, and negative 6x times 2 is negative 12x. So now we've accounted for a bit more of our division, so we'll take it away from our expression. So negative 6x squared take away negative 6x squared should give us 0, this should cancel out. And x take away negative 12x. That's going to be a double negative, will be an add. So it's going to be a 13x. And then plus 6, because we took 0 away from the 6. Now dividing again. So we've done our cubed and squared terms. Now we're doing the x term. And it's 13x divided by x, which will give us 13, which we can place on the answer line. So again, we need to multiply it to take into account the plus 2 that we didn't divide by. So 13 times x is 13x, and 13 times 2 is going to give us 26. So dividing again, or taking away rather, 13x take away 13x is 0, and 6 take away 26 is negative 20. And now we're left with a remainder because we can't divide that by x, so we've got to stop. So it's remainder 20, or rather negative 20. So now we need to write a sentence for our final answer. So our answer is x squared minus 6x plus 13, which we've taken off our answer line at the top, but it's remainder negative 20. Moving on to the next example, we are dividing by x plus 4, and we are dividing x to the power of 4 plus 10x cubed plus 37x squared plus 60x plus 36. So again, dividing by just the x to start with and dividing the first term. So x to the power of 4 divided by x is x to the power of 3. Write it on the answer line. And then realise that we didn't divide by the 4, so now we need to multiply and work backwards to see what we've accounted for here. So we've got x cubed times x is x to the power of 4, which is what we wanted, but then x cubed times 4 will give us 4x cubed. So we've got a little bit extra than what we really wanted because we didn't divide by the 4. But we do want to work out some x cubed terms next anyway, so if we take it away, we've actually found out part of what we needed to find. It's not a problem. So x to the power of 4 take away x to the power of 4 is 0. 10x cubed take away 4x cubed is 6x cubed. And the rest of it, we're taking away nothing from them, so they all stay the same. So moving on to the next step, dividing by x. We've done power 4, so now we do power 3. So it's 6x cubed divided by x, which will be 6x squared. Write that on the answer line. And then multiply it by the divider, again to account for that plus 4 that we didn't use. So 6x squared times x will get us back to 6x cubed. Then the extra bit, 6x squared times 4 will give us 24x squared. So let's take that off. And obviously the first term's going to calculate to give us 0, but the second term got 37, and we're taking away 24. So 37 take away 24 is going to give us 13. So it'll be 13 lots of x squared. And again, the next two terms having 0 taken off, so they stay the same. So again, we're going to be dividing by x. We've done power 4 and power 3, so now we're going to divide our power 2 term. That's 13x squared divided by x, which is 13x, and write it on the answer line. So again, we need to take account the plus 4, so we have to multiply the 13x by what we divided by. So 13x times x gives us 13x squared, but then the 13x times the 4, which is really important here because that's what we're accounting for. 13 times 4 is going to give us 52, so it's 52x. So now we've dealt with that, we can take it away from what we've got left. And we're going to have 60x take away 52x, which is going to give us 8x. And we're taking nothing away from the 36. So then we're going to divide for one last time. So we're going to divide by x again. And we're dividing our x term. So we have 8x divided by x, which is 8. And that can also go on the answer line. And again, we have to take account the plus 4. We didn't divide by that. So 8 times x is 8x. And 8 times 4 is going to give us 32. So now we can take that away. So 8x take away 8x, 0. Again, all these first terms cancel out to make 0. But then 36 take away 32 is 4. So we actually have remainder 4. So now we need to write down our final answer. So we can say that we have 3x to the power of 3 plus 6x squared plus 13x plus 8, remainder 4 as our final answer. Now moving on to the hard question, the presentation of the questions changed a little bit again, but still going to be a similar method. So now we're just being asked to factorize a cubic expression. Now to factorize it, we're going to need to have 3 sets of brackets. We know it's going to be x in it. It's going to need x times x times x to make the x to the power of 3. But we don't know which numbers are going to be in there. So how do we proceed? Well, the first thing is the numbers that go in there, if they divide using algebraic division into our expression, and then we have a remainder 0, we know it'll be a factor. So the things we divide by, let's say that x plus 1 is a factor. If we divide our x cubed expression by x plus 1 and its remainder 0, we know that's going to be one of the brackets. The problem here is that I don't know that x plus 1 is going to be a factor. So how do I work out which factor to divide by? So what I need really is I need a factor to start off with, but I've not been given one. Now the clue here is the -9 at the end. And our numbers, we have to multiply together to make -9. So for example, we could have a +1, we could have a +3, and a -3. And those 3 numbers will all multiply together to make -9. So this is just a guess. This might not be the right answer. We could also have -1 and +3 and +3. Now 9 doesn't really have a lot of factors, so it looks like this is kind of what we're limited to. I guess as well, actually, we could have a +1 and a +9 and a -1, or we could have a -9 and a +1 and a +1. So any of these could be our answer. So again, it all comes down to which one do we choose. And it might be we choose incorrectly, we do algebraic long division, and we get to the end, and the remainder is not 0. and then we're going to have to do the whole process again, but that's fine. And that's kind of built into the question. So there'll be extra marks to account for doing things like that. So with our choices, again, it all comes down to the -9. So I'm going to write -9 down, make a little note of this. And we want to limit our kind of guesses to factors of 9. So we can have 1 and -1, 3 and -3, and 9 and -9. So we want to look at those first. So what I'm going to do, let's rub all of this out because we don't need it. We're going to do algebraic long division. And it's usually safe to start off with the ones because they very often tend to have 1 or -1 as a factor. So let's start off with +1. So let's take x plus 1. Let's check if that's a factor of x cubed plus x squared minus 9x minus 9. So we're going to go through our method. So let's divide by the x and divide the x cubed by the x. So I'm not going to write down our divisions here. We're going to do them in our head from this point onwards. So x cubed divided by x is x squared. Then we're going to do x squared times x and x squared times 1. And I'm going to take those away from each other. That leaves us with 0. And then we've got another 0, so that's unusual. And then we've got our -9x and our -9. Now I'm just going to make sure that I line up the x squared with the x squared column, because when we do our next step now, you'll notice that we've done x cubed, but the x squareds cancel out to make 0, so I don't actually have any x squared term to divide by x. So all we do is we just move on to the -9x. So -9x divided by x is -9, and I'm going to line it up with the whole number column. So we'll see we've got a missing term in the middle because the x squared's cancelled out as well. So we actually skipped a step. Then we do -9 times x, and -9 times +1, which is -9. And what we can see here, so we've been really, really lucky in our first guess, these are going to cancel out and give us 0. So we have remainder 0. So we have proved that x plus 1 is actually indeed a factor. And again, if you start off with plus and -1, you are probably going to get a factor a good chunk of the time. So what do we do next? Well, let's write out what we've got. So we know that x plus 1 is a factor. And if you look at our answer, we've got x squared plus 0x minus 9 on our answer line. So that is also going to be a factor. Our answer is a factor. Now, at this point, what we could do is that we could take x squared minus 9. We could guess another factor. We could guess -1. We could guess 9. We could guess 3. But actually, you should be able to solve quadratic factorization like this. And so if we have, and we'll do this over here, x squared plus 0x minus 9, then you should be able to take the factors of 9. So 1, 9, and 3. You should be able to think to yourself, right, which ones of those will give us a 0x? And it's going to be a 3 and a 3. It'll be a +3 and a -3. So we've factorized the quadratic just using the method you normally use, where we have two numbers which multiply to make -9 and they add to make 0, and we've completed our factorization. So now we can actually write down the final answer. The final answer is x plus 1, which is the factor we got from our division, and then we've got x plus 3 and x minus 3, which are the factors we got from factorizing the quadratic we were left over with. So the kind of idea is, if you've got a cubic to factorize, if you can get one term out of it, and then you do the algebraic long division, whatever the remainder is should be a quadratic that you can solve using the easier methods. And so our final answer is x plus 1, x plus 3, and x minus 3. And it doesn't actually matter which order those factors are in. You know, it might be that you guessed x plus 3 first, and that was the first one you wrote down, and you factorize a different quadratic to get the same 3 brackets. As long as you have those 3 brackets in any order, then you are going to get full marks. So with the next question, let's start off with looking at the factors of the final number, which is a 48. Because then we're factorizing, we're going to get in 3 brackets, and we'll need to kind of guess what the first factor is going to be. Now, looking at the factors of 48, we can think, well, we have 1 and 48, 2 and 24, 3 and 16, 4 and 12. So there's lots and lots of options here. 6 and 8. It's not going to divide by 9 or 10, so it looks like we've finished our list. So there's quite a lot to choose from here. Now, it's probably going to be a good idea to start off with the 1, and then maybe we can look at 2 and 3 and 4 and work through that way. Also take into account the other things you can see here. So, for example, we've got a 40 and we've got a 12 at the start. So think about the factors of those numbers as well when making our guess. And look at those other numbers. I think 41's prime, so there's nothing we can divide with that. But I'm getting the impression that 4 might be an important number in this question, with the 12, the 40, and the 48. So I might want to start off with a 1, or I might want to start off with 4. So I think I'll try 1 first, and then if 1 doesn't work, I'm going to try 4 next. So it's, again, just an educated guess. So let's try x plus 1. Don't forget the negative version as well. It could be -1. So we might try that as well. So we have 12x cubed. We have 41x squared. We have 40x, and we have 48. So we are going to divide by x first. And we divide the 12x cubed by x, which will get us 12x squared. We'll multiply that by a divider, so that's going to give us 12x cubed, and then multiply by the 1 will give us 12x squared. So now we can take away, and that will leave us with 41 take away 12. That's going to leave us with 29x squared, and then the rest is having 0 taken away and stays the same. So we've done x cubed, now let's look at x squared. So we're going to divide our x squared term by the x. So 29x squared divided by x will give us 29x. Then we'll multiply that by the x plus 1. So that's 29x squared plus 29x. Again, I'm going to do the takeaway. So -40 plus 29 is going to give us -11. Oh, it's a negative, take away another negative actually. So it's going to be -69x, take away 48. Then dividing by the x again. So now we're up to the x term. That will give us -69. Then multiply by x plus 1. That gives us -69x and -69. Now I know if I take these away from each other, the -48 take away -69, that is not going to make 0. So I've eliminated x plus 1 as a factor. It is not going to be a factor. So unfortunately, all this work, bit of a waste. Let's rub it out. It's not going to work. And this is going to happen when you do these questions. But again, the amount of marks you get for it will take into account that you might have a few false starts. So let's rub as much of this out as we need to. So why don't we try -1 next? Remember, these factors can be either positive or negative. So let's write in the bits that we rubbed out. And we're going to be dividing by x, and we're dividing the cubed term by x. 12x cubed divided by x is going to give us 12x squared. Then multiply it by the x minus 1. That'll give us 12x cubed, take away 12x squared. Take that off from our total, and we get 41x squared, take away a -12. It's a double negative. That'll give us 53x squared, and the rest is unchanged. Now let's divide by x, and we're going to divide the squared term by x. 53x squared is going to give us 53x. Multiply it by x minus 1, and we'll get a -53x. Now we can take away again, and we get -40 take away a -53. So that's a double negative. We'll be adding instead. That should give us 13x. And then the 48 is having 0 taken away from it, so that stays the same. We're going to divide by x again. This time we're up to the x term. 13x divided by x is going to give us 13. And multiply it by x minus 1, that'll give us 13x, and then minus 13. Now again, if we take these away from each other, we are not getting 0. So actually now we have eliminated 1 as a possible factor. 1's not going to be a factor. So unfortunately, our second guess has not worked either. Now, is there an easier way to this? Do we have to go through this calculation every single time? Well, there's actually a little bit of a shortcut we can use. We don't need to do this again. So what else can we do to speed up this process? Because I had to do 2 quite long calculations to eliminate 1, and we really should be looking at 2 next. So what we can do is we can write down our expression. And what should happen is, if 2 is a factor of this, if we substitute x for 2 in every single part of this equation, all the x's are being replaced with a 2. If this is equal to 0, then this is going to be a factor. So another way of finding a factor is to prove that this is equal to 0. So using a calculator, I'm going to do 2 to the power of 3, which is 8, and multiply it by 12. That's 96. We're going to add on, we have 2 squared, which is 4, and multiply it by 41. That's 164. 40 times 2 will give us 80, so taking away 80 and taking away 48. So does all of this give us 0? So I'm just quickly calculating this on a calculator, and my calculator is telling me that this is equal to 132. That means that this is not going to be a factor. 2 is not a factor. But you'll see that this test was a lot faster than doing the full algebraic long division. So let's get rid of that. So now let's do the same thing, and let's test it with -2. So I'm going through again. I'll swap in all the x's with a -2, and then I'm going to work it out. So -2 cubed will be -8, and multiply it by 12 will give us -96. -2 squared is 4, times it by the 41 is 164, and then -40 times -2 is a +80, and take away the 48. So what does this give us? So again, quickly typing it all into a calculator, just trying to do a quick test here, and I'm actually getting for this 100. So 2 is not giving me 0 either. So I've now eliminated 2 as a possible factor to investigate. Now, I could look at 3 next, but I wasn't wasting your time earlier when talking about these factors and kind of guessing, because, with the 12 and the 40, it might be that 4 is a good factor to look at. So why don't we try 4 next? And hopefully a bit of educated guessing and skipping that 3, maybe you'll get to our answer a little bit faster. So I'm going to have 12, replacing the x with a 4. 41, replacing the x with a 4. Going through all the way, replacing all the x's with 4s. And now let's see what we get. So we have 4 cubed, which is 64, and times it by 12 is 768. Then we have 4 squared, which we are then multiplying by 41. And that is going to give us 656. And you know what? I'm not going to bother continuing. These numbers are so large. And I'm going to take away 40 times 4 and 48. 40 times 4 is going to give me 160. It's not going to get to 0. So I think we can eliminate a +4. But remember, these be positive or negative. So I'm not giving up hope yet. Let's try a -4. And let's look at our expression. We do have a -40, -48. So negative numbers are going to be possible here. The only time you don't want to look into negative numbers is every term in the expression is positive. So we have -4 to the power of 3, which will give us -64, times it by 12. Now we've got a -768. So we're still working with large numbers, but with the next one, -4 squared gives us a +16. And then we times that by 41. And now we've got a large positive number to cancel it out. So this is looking more likely. So then -40 times -4 is going to give us a +160, and then we're taking away 48. So type all of that into a calculator, and I'm getting 0. So it looks like we've found a factor. The factor we have found is -4. So now we've done that, what we can do, we found our first factor. You could use this method, and you could just completely randomly guess the next 2 factors. That's going to be quite difficult, especially since it says 12x cubed. So there might be some kind of fractional factors here, which is going to be impossible for you to find. So what you do is, once you've found a good factor, like x, it's a -4, you've got to think about how the factors actually work. And if you had this in a bracket, and then let's make up a random one just to prove my point here. So let's say we had something like this. You would say the factors are actually what make the brackets be equal to 0. So for this, you'd say that x is equal to 4, or it's equal to -1. And it's because the opposite of what's in the bracket is what makes the entire bracket equal to 0, to make the entire expression equal to 0. So when we're saying that we found -4 as a factor, what goes in the bracket is actually the opposite. So what we need to do, actually, we're not going to divide by x minus 4. We're actually going to divide by x plus 4, because that's x plus 4 is what corresponds to the factor. So we have x plus 4. Set up our long division. You have 12x cubed plus 41x squared minus 40x minus 48. Now we've figured out that we're going to be using x plus 4, we can start our method. So we're going to divide through by x, starting off with the x cubed term, and that should give us 12x squared. Then we need to multiply that by the x plus 4. That will give us 12x cubed, and multiplying it by 4 is going to give us 48x squared. So now we can do our takeaway. I'm going to have a 41 take away 48. That'll give us -7x squared. And the rest is being taken away by 0. So it'll stay the same. So moving on to the next term, we're going to divide through the x squared term. And that should give us -7x Again, multiplying it by the x plus 4 to kind of take into account the fact that we didn't divide by the 4. So that's going to give us negative 7x squared, and times it by the 4, that would be negative 28x. Let's then do the takeaway again, and this time we'll have a negative 40 take away a negative 28, so double negative, so it'll be negative 40 plus 28. That should give us a negative 12x, and the 48, we're taking away 0, so that'll stay as it is. Moving on to the next term, so now we're up to x to the power of 1. If we divide that by x, that's going to give us negative 12. Multiply it back by x plus 4. That'll give us negative 12x. And negative 12 times 4 will give us negative 48. And so if we divide those, so we take those away, we're going to get 0. This is more confirmation that what we have found, x plus 4, is indeed a factor. But the reason why we did this is that now we don't just have x plus 4 as a factor. We also have the answer to our algebraic long division, which is 12x squared minus 7x minus 12. And so what we can do now is we can try and factorize the quadratic. Now, again, we can do another guess and do another algebraic long division, but what we probably want to do here is use another method. So using a normal method for this, we think we've got the negative 12, so what are the factors of 12? So we have 1 and 12, 2 and 6, and 3 and 4. And so if we want two of those numbers which multiply together to make 12, we need to add to make 7. So which of these could make 7? Now, we've got the 3 and the 4, they'll make 7, but there is a bit of a hiccup here. The problem here is that we've got the 12x squared as well. So that means that some of these factors will be multiplied by the factors of 12 as well. Now, if you're confused by this part, you might go back and watch the factorization videos. But we know that x plus 4 is a factor, but with our other ones, with the 12x squared, we've got a few alternatives. Now, we could have something like, we could have a 12x and a 1 to get 12x squared. Or we could have a 3x and a 4x. Or we could have a 6x and a 2x. So any of these are possibilities, and we don't know which one. So we're just going to have to kind of work through all of them. Now, probably start off with the numbers that are closest together. So let's start off with the 3 and the 4. So what we're doing is we're looking for multiplication of these factors, which will make 7. So let's take the 1 and the 12. We could multiply the 1 by 3 and the 12 by 4. Or we could multiply the 1 by 4 and the 12 by 3. Now, none of those are going to give us 7, so we can cross those out. Let's look at 2 and 6. We could multiply the 2 by 3 and the 6 by 4, or we could multiply the 2 by 4 and the 6 by the 3. Now, do any of these give us 7? Doesn't look like it, so we can cross those out. Then the 3 and the 4. We could multiply the 3 by 3 and the 4 by 4, or we could multiply the 3 by 4 and the 4 by 3. Now, do any of these give us 7? Well, 12 and 12 won't, but 9 and 16 will give us 7. 16 take away 9 is 7. So we've actually found our factor. So going back to all of our alternatives, we know that it's going to be a 3x and a 4x, which makes our 12x squared. And we know it's going to be 3 and 4 in the brackets. Now, which way around? Well, the 3 was multiplied by 3, so that's going to go in the opposite bracket. And the 4 was multiplied by 4, so that's in the opposite bracket. And the last thing to do now is think about if it's going to be positive or negative. Now, you wanted the 16 to be, well, actually, it's negative 7, isn't it? So we want the 16 to be the negative. The larger number is going to be the negative. And then we add on 9 to get back up to negative 7. So we want the larger number to be the negative. It's going to be a negative 4 and a positive 3. And now we've got a complete factorization. The answer is x plus 4, 3x minus 4, and 4x plus 3. For a final step, let's say it was all equal to 0. And it might be that it doesn't say factorize, it says solve. And it's all equal to 0. What will we do in this situation? So we're going to think, well, we need to make the brackets equal to 0 to make the whole thing be equal to 0. So we'd have x is equal to negative 4. X is equal to positive 4 over 3, and x is equal to negative 3 over 4. Again, these just being the things you need to make the brackets be equal to 0. And again, if solving this, if this is something that you're confused by, go and have a look at the quadratic equations videos, which is a little extra detail that you might see, because you might see the question phrased in a solve way rather than a factorize way. So moving on to the final question, we're going to try and speed the process up now a little bit. We need to factorize. We have a quite long expression here, but looking at the end, we need to result in a plus 6. Looking at the factors of 6 is going to be helpful. So factors of 6, we can look at 1 and 6, and 2 and 3. So to start off with, why don't we test 1? Take our expression, x to the power of 4, 3x to the power of 3, 3x squared, negative 7x, and add 6, and we're going to test 1. So we write it all out again, but we swap all the x's for 1s. And we're going to see if this equals 0. If it does equal 0, we've got a factor, and we can proceed with our algebraic long division. So we have 1 to the power of 4 plus 3 times 1 to the power of 3. Then we're going to have negative 3 times 1 to the power of 2. We're going to have negative 7 times 1 and the 6. Quickly typing that into a calculator, and altogether I'm getting 0. So it seems like x equals 1 is going to be a factor. What I can do now is we can get rid of this working out, and we're going to do our algebraic long division. Now remember, when we say that x equals 1 is a factor, in the brackets you don't have x equals 1. You're going to have x minus 1, because the x has to be a 1 to make this expression produce 0. So then we're going to write down our expression again, and we're going to start dividing. So first we'll divide the x to the power of 4, and that will give us x cubed. Multiply it through by x minus 1, and that'll get us x to the power of 4, and then minus x cubed. And we can do our takeaway. So that's going to give us 4x cubed, and the rest is going to be the same. Just note that I use a double negative there. We took away a negative 3x cubed, which is why it's now 1 bigger. Then we can multiply through by x again, but this time the cubed term. And that is going to give us 4x squared. Then we multiply that by x minus 1, and that'll give us negative 4x squared, and we can take away again. So again, we're going to get a double negative, so we'll get a positive x squared out of this, and then the rest is going to be the same. So the negative 3 take away a negative 4. Moving on to the next step, we divide by the x again. This time we're up to the x squared term. So x squared divided by x is going to give us x. Multiply through by x minus 1 will give us x squared and minus x. Take away again. Again, it's going to be double negative, so negative 7, it's going to be plus x. So that's going to be a negative 6x and plus 6. Moving on to our final divide by x on the negative 6x, that will give us negative 6. And multiply through by x minus 1, and that will give us negative 6x. And it's going to give us negative 6 times negative 1 will give us a positive 6. And we can see that they line up, they're exactly the same. So when we take them away, we get 0. So we're kind of proving here that the x minus 1 is going to be one of our brackets. And we already knew that, but the point of this is that we now know what the remainder is. So we have x minus 1 in a bracket, and we have x cubed plus 4x squared plus x minus 6. That's the first part done. Now, in this case, we don't have a quadratic left over, so we can't just use kind of factorizing quadratic methods. We've got a cubic left over. So we have to repeat this process now, do everything again. So we have x cubed plus 4x squared plus x minus 6. Again, we know the factors of 6 will be 1, 6, 2, and 3. So why don't we test 1 being a factor again? So we'd have 1 cubed plus 4 lots of 1 squared plus 1 minus 6. And if this equals 0, we know that 1 is a factor of this expression as well. So that's going to give us 1 plus 4 plus 1 take away 6. And that does actually give us 0. So we found a factor, x equals 1, of this as well. So now we're going to repeat this and do another algebraic long division. So I'm going to rub everything out. So if 1 was a factor, we're going to divide through by x minus 1, because if x is 1, then x minus 1 has to give us 0. And we're going to divide through by the remainder of the last one we did. So x cubed plus 4x squared plus x minus 6. Dividing through first by the x and the x cubed term, that should give us x squared. Then multiply that by x minus 1, and that'll get us x cubed minus x squared. Take those away from each other. It's going to be a double negative, so that'll give us a 5x squared, and the rest stays the same. Moving on to our next division by x, we divide the x squared term, and that should give us 5x. Multiply that through by x minus 1, and that'll get us 5x squared, and 5x times negative 1 will be negative 5x. Take those away, and again, it'll be another double negative, so it'll be 6x minus 6, and we are going to divide by x one last time. It'll be the 6x we divide. 6x divided by x is 6. Multiply through by x minus 1, and that'll give us 6x minus 6. And if we take those away, we're going to get 0. Again, proving that this is going to be one of our brackets. So now we've got the x minus 1 that we got from our original division. We've got a second x minus 1 that's a factor of the cubic expression. And we've got the remainder, x squared plus 5x plus 6. So all we need to do now is to factorize the quadratic, and it's actually one of the easiest quadratics to factorize. I can see straight away what are two numbers multiplied together to make 6, add together to make 5. It's going to be 2 and 3. So it'll be x plus 2 and x plus 3. And now we factorize the whole thing. We've got our final answer.